studying in class, I'm actually going to do this one for you, with you, I guess I should say, and then the rest of them I'm going to kind of let you go through on your own because you spent more time on the rest of the material. But notice it says a ratio of A to B. So the first thing that I'm going to do is I'm going to find where my ratio is at, and I'm going to label it A and B. So out here on Scratchwork, I'm going to say that A equals 1 and B equals 3. Okay. This one actually won't, you can't use the midpoint formula for it. You are going to use the midpoint formula on some of them, but it doesn't want the middle point. It wants the point that's at a ratio of 1 to 3. Okay. And so then the next thing it says is that your A point is your X1, Y1. So your first point, you're going to label X1 and Y1. I'm just going to make a note over here of that. Your second point, you're going to label X2 and Y2. So we're just going to go ahead and do that. And now we have everything that we need to know in order to plug it into our formula to figure out where it cuts this line at. So here's our formula in purple. And this is simply plugging and chugging. I know it looks really intimidating, but all I'm doing is I'm replacing the letter with the number that it equals. So notice it starts off with B times X1. So I'm going to go over here and I'm going to find my B, which is 3, times my X1, which is 2. And I'm going to do my plus sign. Next thing it says is A times X2. I'm going to come over here and I'm going to find my A, which is 1. And I'm going to multiply it by my X2, which is 10. And then on the bottom down here, it says all over B plus A. So I'm going to do all over, my B we said was 3, and my A was 1. Okay. Turning the chat on. Do you want me to go back over where those numbers came from? Or do you guys, green check if you, I'm going to make the polling private so you can't see them. 4. Yeah, 16 over 4, which reduces to 4. Awesome. Does anybody see a test-taking strategy that might be helpful here? Raise your hand if you're like, wait, I know this. I know what I'm doing. I see something. I want everybody else to see it too. Yay, Grace, you want to grab the mic for us and tell us? Okay, so since you got your first answer, if you look at the answer options, only one of them have a 4 in it, and it's in the right spot, so you automatically know that that's your answer. Gracie, saving us all some time. That's what's up. Hey, there's only one 4, and it's in the right spot. So, y'all, if you use the process of elimination, we already know it. We're golden. All right, if there was 2 that had a 4 in it, then you would need to go and find your Y values as well. But hey, since it's multiple choice, we may as well use that strategy, right? That's a shortcut. Good catch, Gracie. Okay. Here we go. Now I'm going to actually let you guys start these. So I'm going to set a timer. It says, which pair of rectangles are similar polygons? All right, so I'm going to turn the chat box off for a minute. Adam says proportional, divide the sides, the ratios, their numbers. Oh my gosh, you guys are like making me super happy right now because typically the first answer I get is look at it. And look at it is not the right answer. I mean, you can tell somewhat by looking at it whether it's totally not possible to be similar or not, because similar means same shape, different size. But don't ever answer on a test simply by looking at it. We need to check to see if the sides are proportional. So yeah, we need to check their ratios. So let's do BC. All right, I'm going to take the smaller side of C, which is 6, and the smaller side of B, which is 3. And I'm going to put those in a fraction. And I'm going to see if that's proportional to the bigger side of C over the bigger side of B. Now you can either reduce each of these or you can cross multiply. But if I cross multiply here, I get 24 equals 24. So they are proportional. That means that they are similar. All these people with coffee mugs, y'all are awake today. I love it. And then for the other ones, again, you can check the proportions to see. But those are not going to be similar. So let me show you what one of those looks like, and then we're going to move on. So if we checked A and B, we would take the biggest side of A with the biggest, biggest side of B. So these might just be rotated a little bit. So the biggest side of A over the biggest side of B, and the smallest side of A over the smallest side of B. And when we cross multiply here, we get 16 equals 18. Those are not similar. But that one could have been a little tricky because notice how they rotated it. That one could have caught some of us. It almost caught me, to be honest. Okay, so you guys have them right on the board. Let's keep on rolling. Use your polling tools. Green check will be true and red X will be false. I'm going to give you guys some more time because you haven't pulled in yet. So for the first one, angle T is congruent to angle G. True or false? If you're not pulling in, just be warned that you might get moved to the back on track room. Y'all know the drill. Just move yourself back. Okie dokie. So it looks like for those of you that have polled, hang on. Where's my light? Oh, okay, there it was. Y'all, 54 of you haven't even responded. It's partly my fault because this lesson is just a whole bunch of information thrown down your throat. We gotta get better than that, though. But for those of you that did respond, that is a true statement. In similar figures, the corresponding angles are congruent. Nice job. Okay, we're gonna move on to the second one. Segment TR is congruent to segment GL. Go ahead and pull in. All right, make sure you're polling either true or false. Let's see what we got here. Okay, so only 47 didn't poll that time. Goodness gracious, y'all. My heart hurts. It hurts bad. Okay, so when you have similar figures, I'm gonna turn the chat box on. Are the side lengths gonna be congruent in similar figures? Any ideas? Let me scroll all the way down. No, yeah, they're flying in now. Similar means same shape, but different size. So you're dilating it. You're making it bigger or smaller. So the angles are going to stay congruent, but the side lengths are definitely going to change. They're either going to get bigger or smaller. So that one is false. Let's see, I should have marked these. This one's true, this one's false. Let me clear out the polls. This one looks Interesting. This says that TR over RI is going to be equal to GL over LE. Go ahead and pull in. All right, last chance to get your polls in. Okay, so let's see here. We had the majority of us saying true, but some of us are saying false. So let's check it. Remember, in similar figures, the corresponding sides have to be proportional. So if we take TR has to correspond. It's the first two, so it has to correspond to GL. So on the top we have TR and GL. That's a good sign. And then on the bottom we have RI, which is the last two. And the last two have to correspond, of course, with the last two. So RI and LE also correspond. So that is a true statement. So I'm going to kind of throw a trickier question at you. It looks like, okay, well, anyways. How would that have been a false statement? Any ideas what would have made that a false statement? Okay, so different order, if it says congruent, if it's a swiggle, change any one of the letters. Yeah, okay. So here's kind of what I'm getting at. If it had had this first fraction the same, TR over RI, and then it had said TR corresponds to LE and RI corresponds to GL, if it had just changed the order, if it had just flipped a fraction, would that still have been a true statement? Getting tricky here. What I've done is I've taken, like, for example, if we go back to these figures, I put them in the wrong order. So, for example, we know B and C are similar, but I cannot say that 6 over 3 equals 4 over 8. Right? Because those sides don't correspond. It doesn't work. When you set up your proportions, they have to be corresponding sides. So don't assume just because it's a proportion that it's always true. You need to make sure that the sides are actually corresponding. Make sure that they actually go together. Okay. All right, for the next one, let's move right on down. We're down here at angle R is congruent to angle L. Green check for true, red X for false. That's true so far. Wait a minute, what are these? Oh well. So let's check to see if that's true. Angle R is the middle one. Angle L is the middle one. And it says congruent. Are your angles congruent when you have similar figures? Yeah, the angles are congruent. Now remind me, are the side lengths congruent when you have similar figures? Nope. Good. Alright, so for those of you that are still with me and paying attention, y'all are doing great. The other thing that we can all agree on, and I've heard this from several of you, you guys did a great job. I think that we can all agree that TI and GE are corresponding sides, right? TI does correspond to GE. They're in the same position, so we know that they correspond. So we are definite that these are corresponding sides.